Hello everyone. Today we are going to discuss the next geometrical concepts that are given in the chapter. So today's first concept or the first geometrical concept that we'll discuss is curves. So what are curves? So there is some picture that is coming right now in our mind. So before going to that, let us first go to the definition of curve. So what is a curve? It is a line or an outline which gradually deviates from being straight for some or all of its length. Now let us see the next point. Curve in everyday usage means not straight, but in terms of mathematics it can be straight too. Moving on to the third point. Curves are generally drawn without lifting the pencil from the paper and without the use of a ruler. So why I have not discussed directly the definition of curve? Because unless and until all these 3 points are clear to you, the concept of curve will not be clear. So you can see with the help of the diagram that is given here. If we see all these 7 diagrams that are given, among these, all these 6 diagrams are clear from the first 2 points. But if we see this, particularly this number 4 diagram, almost everyone would think that this is not a curve. But if we see that last point, that curves are generally drawn without lifting the pencil from the paper and without the use of a ruler, then this satisfies. How? Because curves are generally such type of figures or geometrical, you can say, diagrams which are mainly drawn freehand. That means they are drawn without the help of any other geometrical instruments. They are directly drawn with the help of the pencil on the piece of paper, and without lifting the pencil, we have to freely draw it, also without the help of a ruler. So since we are not using any ruler and we are drawing it freehandly, so definitely even a straight looking line, it can be considered as a curve, because it is not a perfectly straight line. It looks like a straight line, but still we can consider it as a curve since it is drawn freehandly. So according to that, if we consider that, then this 4th number diagram is also a curve, and the rest of them are definitely curved because they are having some kind of a bend. They are not completely straight. After some time they are taking a bend. You can see here also it was straight and suddenly it deviated from its path. So it is a curve. So unless and until all these 3 points are clear to you, the definition of curve is not that easily it can be said that like this is a curve and this is not a curve. No. Even this straight looking line is also a curve. Clear? Now moving on, the types of curve. So definitely there are different types of curve. Already we have seen some in the earlier slide just now, a while ago. So first type of curve is a simple curve. The name is simple, but it's not that simple. You can see here, a simple curve can be defined as a curve that does not cross itself. For understanding this, you have to go back to the earlier slide. You can see here, these curves, say 1, this 2, then 4, then 5, then 6. All these 4 curves are 1, 2, this 4th number curve will not be considered. It is not considered in any of these types. But this 1 number, 4, this 5 and 6, these 4 curves can be considered as a simple curve, while this number 3 and number 7 will not be considered as a simple curve because they cross over. Crossover means they after completing their diagram, you can see it has been extended. In this case, in number 7 it is extended. Here also, if we consider this small triangle like structure, it is totally complete, but still after that it is making another structure, you can see. So it is extending itself. Clear? So this extension does not fall under the category of curves, or you can say under the category of simple closed curve, because according to the definition of simple closed or simple curve, you can say either it is closed or not, that is a different matter, but under the definition of a simple curve it should not cross over, but in those two cases it has crossed over. Already the shape is complete, still again it is crossing over, so the curve is extended, you can say. So those two diagrams, number 3 and number 7, will not be considered as a simple curve, and the rest of the 4 curves are simple curves. Clear? Because they did not cross over. Now moving on to the next, closed curve. So by the definition itself, we know that a curve can be closed when the initial and the end points are the same. And just its opposite, open curve. An open curve can be considered as a curve where the initial and the end points are different. So let us see one diagram, it will be clear to you. Obviously this is what? This is open, you can see it is totally open, and here it is closed. So simple. Why? Because the initial point from where it started and the end point where it finished is the same thing. And in open curve, this initial point and end point will never meet each other. They are different. It will end at different place, it will start at different place. So this is the difference between an open curve and a closed curve. Clear? So these are the 3 types of curve. Now moving on, parts of a closed curve. Now closed curve has also some parts. Let us see what are those parts. In a closed curve there are mainly 3 parts. Which are those? Interior, that is the inside of the curve, then boundary, that is on the curve, and exterior, that is the outside of the curve. So if you see this diagram, some points are inside, some are outside. So let us see which are inside, which are outside. In the above figure, the point A is in the interior. You can see A is totally inside, as if it is fully engulfed by the curve. Then point B is on the boundary of the curve, and point C is in the exterior, means outside of the curve. So just looking at the diagram, it is very much obvious, it is very much clear. Now the next point, the interior of a curve together with its boundary is called the region. So if you are told what is the region of the curve, then this shaded portion and all the points which are inside this shaded portion, all together we can consider it as the region of the curve. Clear? Now moving on, polygon. What is a polygon? The definition of polygon says a simple closed curve. Now look, all these are related, interrelated. We have just now learned what is a simple closed curve. Clear? We have just learned means what is a simple curve and what is a closed curve. So if a curve which is both simple and a closed curve, and if it is made up of only line segments, then it is called a polygon. And also there is a mandatory rule that how many line segments should be there? There should be at least 3 or more line segments. Only then we can say such a structure as a polygon. So you can see some structures here. You can see here how many segments are there? 1, 2, 3, 4. So more than 3 or more than 3. Here it is 4. Here also it is 4. But in these cases, they are not polygons. Now you might say there are more than 3. 1, 2, 3. And here are obviously 1, 2, 3, 4. But can you see one thing? That although there are line segments, more number of line segments, more than 3. But are they simple curve? No. Neither they are closed. Here in this case, it is not closed at all. It is totally open and it has crossed over. So it is not a simple curve. Clear? Here also it has crossed over. Here in this case, it has crossed over. So it is not a simple curve. So for being a polygon, mandatory it is that it should be closed, it should be simple, and it should be made up of at least 3 or more than 3 line segments. Now next, sides, vertices and diagonals. Now looking at this diagram, we will be doing it. So what is sides? The line segments forming a polygon are called as sides. These are sides which forms the polygon, outer structure of the polygon. So these are sides. Which are the sides? AB, BC, CD, DE and EA. You can look at the diagram, they are very obvious. Now next is vertices. The meeting points of a pair of sides is called a vertex. So wherever these two sides, means pair means two, so wherever any two sides meet, that point is called vertices. What are the vertices here? A, B, C, D and E. Next, what are diagonals? A diagonal is a line segment connecting two non-consecutive vertices of a polygon. Two non-consecutive vertices means the neighboring vertices are called the consecutive vertices, one after the other. But if they are non-consecutive, say D and B, they are non-consecutive, they are not nearby, or they are not the neighbors, so they are called non-consecutive. So if such type of a line segment is there which are connecting two non-consecutive vertices, then they are called diagonals. So there are how many diagonals here? AD, BC, AC, EC and BE. Now you have been thinking, what are this bar? We have given this bar because in order to represent a line segment, because these are all line segments. Diagonals and the sides are line segments. So we have given this bar. Now moving on to the last topic of today's class, that is adjacent sides and adjacent vertices. Just now we have learned what are sides and vertices. So just by looking at the definition, it will be clear to you. Any two sides with a common endpoint are called adjacent sides. Means which are the neighboring sides? They are the adjacent sides. Say CD and DE, they are the neighboring sides. EA and AB, these are the neighboring. So whichever are the neighboring sides. So neighboring sides will have a common vertex. So if they have a common vertex, then they are the neighboring sides and they are called adjacent sides. So these are the adjacent sides. AB and BC, BC and CD, CD and DE, DE and EA are the adjacent sides. Similarly, there are adjacent vertices also. Say D and E, E and A, whichever are the nearby, neighboring, they are called the adjacent vertices. So that's it then. I hope you will have understood it. You can go through your textbook again. You can draw the diagram by yourself and check for yourself which are the terms that have been discussed in today's class. So that's it then. Thank you and have a nice day.